Our reverse array in place algorithm is not going to be very much code at all. We will start by defining our function, reverse array in place, and passing in an array as a parameter. We are not going to be defining any new arrays in our function, so the first thing that we will be doing is writing out a for loop to iterate through our array width. We will say for variable I equals 0, while I is less than array.length, I plus plus. Now, inside of this for loop is where all the magic happens. What we want to do is switch the first element of our array with the last element of our array. We want to switch the second element of our array with the second to last element of the array, and so on. We will do this by using a temporary variable. So we will say variable temp var equals array at position I. We now have the ith element of our array stored in our temp variable. Now we want to set the ith element of our array equal to its counterpart. So if this is the first iteration, for example, I would be 0. And we now want to set the first element in the array equal to the last element in the array. So we say r at position I equals r at position r dot length minus 1, which is the last element in the array, minus I. This I is what makes this whole element the counterpart of this element. For example, if we are on the third iteration, then I would currently equal 2. So this would be the third element in the array, and this would be the third to last element in the array, because this I is taking us back 3 places from the end of the array. So we have our first element stored in our temp variable up here. We have rewrote our current element to be its counterpart with this line here. Now we want to rewrite the counterpart, or this, to be equal to the current element. So we say the counterpart, or r at position r dot length minus 1 minus I equals our temp variable, which has the element at position I stored in it. And that is how it is done. Pretty cool, right? We first store the element at position I in our temporary variable. We then rewrite the element at position I to be its counterpart. And then we rewrite its counterpart to be the element that was originally at position I. We cannot simply rewrite the counterpart by doing the opposite of this, because we already rewrote what array at position I is. Then finally, down here, we want to return the array. Now, this seems like it should work correctly, but it actually won't. This is because we are looping through the whole array in this for loop. So as we go through the first half of the array, we are correctly reassigning each element. But then as we continue through the second half of the array, we are switching every element back again. So if we ran this function right now, we would get back the same exact array that we put in. We can fix this by only looping through the first half of the array. So we will change this for loop to say, while I is less than array.length divided by 2. That will take us through only the first half of the array, and should solve this problem for us. Great, that is our reverse array in place algorithm. Let's make sure that it works by testing it in the next lecture. See you there.